Hey guys, in this video I will show you the basics of web application testing, where you can train sites and tools to help you, and how to work with Burp suite and ZAP proxy. So let's get started. Before we look at the testing itself, let's take a look at a few different tools that already give us some detailed information that we can use when testing web applications. The first such tool, for example, is Vaporizer, which is like a browser add-on. As you can see, I already have installed. The moment I go to, for example, www.tesla.com, when I click on the Vaporizer add-on, I can immediately see the technologies that the site uses. We can see that it uses Drupal. We can see that it uses PHP as the programming language. We can see, for example, the JavaScript framework React version 18.3.1. We can also see other libraries that the site uses. We can also see various security mechanisms like HSTS and so on. With that said, actually already with the JavaScript framework, where we see a specific version of that React framework, we could just be tracking down specific vulnerabilities for that framework in that version. Another tool like that is WebWeb, which basically does something similar. However, not all sites or enough sites are trying to fight against these tools. And Tesla, for example, doesn't completely return all possible information. Like, for example, Vaporizer returned to us. Which actually this blocking of this enumeration quite often works on the basis of what's called a user agent, where really the site is trying to figure out whether we are just some robot or some program that's trying to find out things about the company, or whether we are actually a human here and we are browsing the site with the browser. Then another tool like that is the WebWoof tool, which is used to look at whether or not the site has some sort of what's called a WAF or Web Application Firewall. So as you can see, again, Tesla is trying to combat this, of course, and so let's try to put another site. Let's try Google. And here we can see that WebWoof didn't detect any WAF technology for us on a Google. Let's take another look at, for example, Cloudflare, where actually Cloudflare itself is actually a WAF technology. So let's see if it also uses such technology itself. And as you can see, really Cloudflare is a WAF behind Cloudflare. So the moment you have a page where you want to check if some WAF technology is accidentally overloaded, just use this tool. Another thing we can look at, so nowadays a lot or most sites use encrypted communication. The moment we click on the padlock in Firefox, we can look at the details of encrypting that communication. Here we can see that the technical details, and we can see here that the communication is indeed encrypted and what protocol it's encrypted using. We can see the same thing using another tool, and that tool is SSL scan. All we have to do is type SSL scan and the address of the site in the command line. At that point, we actually get a listing of what encryption the site supports, what protocols, if it's TLS version 1.2, another, for example. We will get information about what encryption the site actually uses, if it's using some outdated encryption, where some different types of attacks could be carried out, and so on. So for this, it's definitely a good idea to use the SSL scan tool. With that said, overall for testing web applications, we can use various automated tools just like Nessus, OpenWASP and the like, which we showed in another video. We can of course also use specialized tools specifically for automated testing and scanning of web applications like Acunetics, like Burp scan or ZAP proxy. With the caveat that whether it's Acunetics or Burp Suite, they only allow scanning in the paid version. Therefore, today we'll mainly show you ZAP proxy as well and how to do an automatic scan of a web application completely for free. Of course, next we can use tools like Nmap, which also has a number of scripts, so it can detect various interesting things on the web server. We can also use other tools like Nikto and so on. With that said, now you can see how to actually downright use Nmap for vulnerability scanning and scripting usage directly for web applications. In order to know where to start or what to follow, applications are most often tested according to the OWASP standard. We can look up the OWASP testing guide, where if we just look at the OWASP site, we get the whole guide, which is in the latest version 5.0. If we click on the stable link here, we can see what all we should actually be testing. We can find an instruction to this and penetration testing and so on. It's nice to read these different things with the fact that we have a category here afterwards for web application security testing, and we can see here what all we need to do. For example, fingerprinting the web server, which we can do right now with our Webalizer tool as well. You can also see here what all we need to test. Already it's testing HTTP methods, testing roles and so on. There are a lot of tests that you should do, and a lot of those tests are what the automated tools will do for you. Some of those tools don't do those tests quite right, and that's why it's always a good idea to do manual testing whenever you are testing a site, of course, and not just really on those automated tests. However, if you follow this guide, I dare say that nowadays you will do like 80, maybe 85% of what you should actually test on a web application. This is because the materials are not exactly up to date, and for example, when you test modern application that have some new structure like front-end, API and backend, you don't quite hit all the areas. For this reason, it's good to already have some know-how and know how to really test even modern web applications and stuff like that. Before we take a look at how to test these different things, let's first take a look at the very most common vulnerabilities, which are actually called the OWASP top 10, and they are actually the top 10 most common vulnerabilities in web applications. Just search for OWASP top 10 or you can click through to the OWASP website. Here you can see that there should be a new actually of those vulnerabilities coming out in the near future. However, if you scroll down a little bit, you can see here that we still have the 2021 inventory, and in this year when they did this inventory of the top vulnerabilities, you can see that the most common vulnerability was what they called broken access control. Then some cryptographics, flaws, injections and so on. With each of those vulnerabilities, of course, you can click here, read, see what they actually mean, and so on. For example, here you can see a broken access control. We have some description of what it actually means, what actually happens, how to defend against this vulnerability, and in terms of penetration testing, we have some options or descriptions of scenarios of how we should, for example, test the vulnerability. Those scenarios are quite often very simplistic, so it's really good to have some know-how at this point in time when testing these vulnerabilities. However, today we are going to go through the basics and show you how to actually scan a page with, let's say, an automated scan, but we'll also show you how we might do it manually. To make sure we don't get lost in the testing, it's a good idea to download the so-called OWASP web testing guide checklist, which you can find on GitHub. It's a pretty well crafted Excel so that you don't actually get lost in the testing and know your way around. You can download it here and I will show it right away. It's actually a checklist which is processed according to the testing guide. That is, the file is diving into different pages according to those categories. Here we see information gathering and we even see a description of vulnerability and even tools that can be used to detect or test that vulnerability. Here, for example, we can see configuration and deploy management. Really, if you follow this, you are going to, like I said, test, let's say, some 80-85% of the things that should be tested on the site, with the ability to see what tools you can use to do that. Obviously, you can see here also like Nessus and things like that. Or of course the tools that I was talking about, for example Nikto, but what you can often see there are just tools like Burp Suite and ZAP proxy. Because Burp Suite and ZAP proxy are really basically in manual penetration testing almost either say 90% enough to really reveal almost all the vulnerabilities in a web application. Here we can see other categories like data validation testing, and everywhere you see Burp Suite and ZAP tools. So you can play around with the workbook, of course. If you enable editing, you can of course write down some status. That way you can come back to that testing at any time and you won't get lost in it. You test here and you know that you have tested the category here, for example with the possibility of some sort of result entry here, with the fact that you can actually see some sort of agenda at the bottom of each sheet. So the moment you click somewhere in a vulnerability and you type pass or issue in the result, it will of course also mark it green or red. This workbook has a number of other things in it. There are some references, some risk assessment calculator, a summary of those vulnerabilities, and a list of common weakness enumerations. So you can definitely play around with this workbook here. You can use it in testing so that you don't actually get lost in the testing. Now we are going to get into demonstrating tools like Burp and ZAP, starting with Burp as the first tool. This tool comes pre-installed by default in Kali Linux, with the Kali Linux having a so-called Community Edition pre-installed by default, which is stripped down version that unfortunately doesn't support just automatic vulnerability scanning, for example. When you run Burp for the first time, you can use a temporary project that is deleted when Burp is closed, or you can of course save the project directly somewhere. At the moment we will just use the temporary project for demonstration and give next. The first thing we are going to show is it's good to see some settings for the proxy. If we put proxy setting, we can see that Burp starts listening to us on the local host on port 8080. In order for us to actually communicate through the tool here, we have to actually set up our proxy in the browser first. This means that we have to go to setting and in the browser, put proxy settings and put the proxy configuration manually and set the browser proxy to our proxy. The moment I give OK and now type into the browser, for example google.com, then immediately the communication starts to go through our Burp, and we can play with the requests in different ways. We can put them in different modules and try different things with them, what we need, but in order for the Burp to actually catch the SSL communication, that is to see into the encrypted communication, we need to generate a certificate from the Burp first, which you do by giving an export, a certificate, and saving it somewhere. And then after you save the certificate, you need to import it into the browser. You do that again in the browser settings. And you import the certificate for the Burp. As you can see, I already have the certificate there, of course, and that's why Burp can actually see into the SSL communication. The moment you don't do that, of course, if you go to a site that uses SSL communication, that is HTTPS, the browser will tell you that there is no valid certificate. Let's demonstrate this interception of SSL communication. The moment we turn off our proxy interceptions of those requests, we see that indeed when we put google.com and back on, it doesn't intercept those requests. And when we look at the certificate that the browsers see now, we see that really when we click on view certificate, we really see the Google certificate here. Whereas if we go back to the proxy settings and actually send the request through the Burp tool again, at this point the communication has started going through the proxies again, and at that point you will see that the certificate in the browser has changed to the certificate of our Burp. I mean, it's no longer the Google publisher, but their sports figure, which is just the publisher of that certificate from Burp. So we can actually read that encrypted communication, and we have basically done a man-in-the-middle attack a little bit. And again, we are intercepting those requests so that we don't have to keep going around setting everything up in this complicated way in the settings and click around in the settings. So let's show another browser add-on that's going to make this a little bit easier, so that we don't have to keep configuring that proxy in the settings. The tool is called Foxy Proxy, with the fact that again, as you can see, I already have it installed. You can install it by putting Foxy Proxy add-ons into Firefox and just adding it. Once you add it, install it, you can configure it in different ways. The moment you click on the options button, you can configure any proxy. You can configure more than one, as you can see. I already have Burp ZAP configured, but for testing purposes, I will recreate the test here. That means we need to specify a host name, we need to specify a port. If we would be using a username and password, obviously that as well. And the moment we save that, we can see that at the point in Foxy proxy, I have another possible proxy here called test. But as you can see, it's running on the exact same port as my Burp ZAP that I already had set up. So at that point, when I go into my browser, I put Google back in here, so I don't have to go into the settings anymore, and I just click on my proxy where I want my requests to be captured. And at that point, when I go into Google again, you can see that there's been some refresh and there's been requests added to the history. With those individual requests that we actually capture, then we can work with them in some way. We can put them into different modules so that we can just see if there are any vulnerabilities on that page. In addition to the classic proxy capture, Burp offers modules like Intruder, Repeater, Sequencer, and so on, where each module takes care of something different. The Intruder is actually used for so-called fuzzing, where we can use brute force on some password, for example. We can try to load some payload into some input, for example, for cross-site scripting and so on. Repeater is used so that we can manually play around with the request and stuff like that. So we can definitely use a number of these modules. The moment we talk about the Intruder, it basically offers us 4 types of attacks, with the fact that just for now, for the sake of demonstration, we just need the sniper and mark the place we want to basically attack. We put in the payloads that we want to put into that location, and that way we could just put in, for example, login credentials or some payloads and stuff like that. Then we would give a start with the fact that we are not going to do that now. We will show that later when we attack the test site. Another one of those modules is the Repeater, which, like I said, we can manually play with that request. We can try to call out that particular request and see how it responds and so on. Then we have these other modules, like I said, sequencer, decoder, and so on. Within that proxy, we can of course intercept that request on the fly. For each request, we don't just have to wait for it to drop into the history. That's what the intercept tab is for. If we check intercept on, the moment we go to the Google site, as you can see, Burp will immediately intercept that request for us. And as you can see, we can use the forward button to go to the next request. So as you can see above, Google is still working, or rather the browser is still working with that Google. That is, it hasn't finished all those requests that actually originate there after we sent the query to google.com. So Google is still running, those requests are still being captured, and here we could edit them in real time, or using of course that forward button to go further. To skip forwarding all the requests, click intercept off. So this way we can simply intercept the requests, then we work with them in different modules. But as I mentioned before, we don't have to use the request only for working in those modules, but we can probably save the requests somewhere else so that we can work with them in other tools such as SQL map and so on. So when I send the request to the repeater, I can copy the whole request and save it in a file, and then use the file with the request in SQL map, for example. So if I put another request, put the request in, save it, and then I would write SQL map dash R request. So I could use SQL map directly to use that request like that and look for vulnerabilities in that particular request. Let's take a look at the next tab, and that's the target tab, where you can actually see a list of all the possible targets that were triggered the moment we launched Google. Of course, if you would like to target a specific page, it's a good idea to add it to your scope. And then you could scan the page. However, as I said, the community edition of Burp doesn't allow scanning. But we can see what all Burp would search for if the scan work, of course. So that's a little bit about Burp and how to actually work with it. And let's take a look at the next tool already, and that's ZAP, which is just a tool directly from OWASP. ZAP is not installed in Kali by default. You need to install it there. You install it by actually giving yourself apt-get install ZAP proxy. Oh, sorry, I'm not root. And as you can see, I already have version 2.15. ZAP as well as Burp at the beginning offered us the option to either save a session or use a temporary one, so ZAP does the same, of course. For our testing purposes, we will only use the option without saving the session. So now I have got some add-ons running here. I'm going to quickly update them now, and we'll come back in a moment. And I will show you which add-ons are good to load for some automated testing. ZAP looks like this. For some people it may be more clear, for some people it may be less clear. For example, I prefer to use ZAP for the reason that I use one big monitor where I have everything right in front of me, and I don't have to deal with any modulation like intruder, repeater, sequencer, and so on. So I prefer to use ZAP. Now if we look at some basic things, just like with Burp, we had to generate a certificate to be able to examine SSL communication. So actually if we click on tools, options, and so we can find the proxy settings. Here we can see that we are also running on a local host on port 8080, and here we have a server certificate. So just like we actually generated and stored a certificate from the Burp, we are going to do the exact same thing here. Here we would put save, we would save that certificate, and then again we need to import that certificate in the browser settings. At this point, I can work with it exactly the same way I worked with the Burp. I can click here that I want to capture everything through our proxy, which is captured, and the moment I look at the history here and I bump sum again, for example Google, I can see that I'm capturing all those requests again here, just like I used to capture them in Burp. I can look at their request and their response. To make ZAP work a bit better, especially for some automatic scans, let's first look at the so-called add-ons. Looking at the add-ons here, I definitely recommend having active scanner rules, beta and alpha installed originally from the marketplace. If you click over to the marketplace, you can click here, for example, fuzz AI files, check and install selective. At this point, it actually automatically installed those add-ons, and if we look now, here is the installed add-on. A lot of the add-ons are actually installed by default. However, like I said, I definitely recommend installing active scanner rules, beta and alpha, advanced SQL injection scanner, which then tests a lot of more payloads than just the base. I recommend to install community scripts and custom payload. I also recommend installing fuzzDB files. And I definitely recommend install JWT support. And definitely passive scan rules alpha and beta by default is always installed only passive scanner rules. And then I definitely still recommend it Python scripting, community scripting, scripts and custom payloads. With the caveat that you can of course install other things. I'm sure there is a lot of other stuff in that marketplace that you can install. Here, for example, JSON view, Kotlin support and so on. So you can definitely install all of that right into the ZAP. Once you got the modules installed, then when you want to start scanning, let's say a page, first of all you can use quick start where you can put automated scan or manual explore. You put the Explorer URL in here and you can play around with that right away. With that said, of course, you can do the same thing so that the moment you actually go to the Google, you turn on the proxy here and you write, for example, www.microsoft.com. So at that moment we capture all those requests again here, and just like we had some scope in Burp, we can do the same here. And actually what the ZAP does is possibly trying different rules that detect vulnerabilities. So it detects vulnerabilities, for example, from the site banners, from the site versions, from the headers. So it's already looking at the headers. So we can actually see that we are already seeing several potential vulnerabilities in our whole scopes. And to filter out the correct vulnerabilities, for example, just for Microsoft, we can just right click, put include in context and put default context. Of course, you can create a new context and then you can see those contexts up here. That is, if I click on it, I can see it here, or you can create a whole new context here. And then the moment that Microsoft is marked as just the default context, then if I check show only URLs in a scope here, we can see that we have already filtered out vulnerabilities for just that separate Microsoft. And then if I uncheck that again, I can see here that I have vulnerabilities for Google and so on. So this way I can then target vulnerabilities just for a specific site, and of course here it's vulnerabilities just from the passive scan. We are going to take a look today at both some automated active scanning, and we are going to look at how one may go about some, let's say, manual testing. Before we start testing, the first thing that we can do, if we have, for example, this Microsoft page, we can use what's called a spider, either an Ajax spider or a classic spider, which actually does this. It crawls all the links within that page, and it actually gets all the possible pages that we can then attack in some way. If I click on the advanced tab here, we see a couple of different options for setting the maximum depth to crawl, which means how deep it actually goes from that base page. That is, if we have a basic page and we have a link on that page, it will crawl that link. If there's another link on that other page, it will crawl that link as well, and it depends on how deep it goes, as far as where we actually want to go. If we set it to 0, it means that ZAP will crawl all the links, which can be a problem with large web applications. And when I start, you can see what it actually does here. ZAP is trying to search that Microsoft page, and the moment it finds something just like GitHub, you can see that it's out of context and it doesn't give us any output at all. That means that the process stops, which is nice, so we are not actually scanning some other page. Here we can already see what's loading into the folder. Suddenly we have a lot more files and everything. So I'm going to stop it now because I wanted to show this mainly for the reason that we are going to get like 2 basic files that are just important for each page. We have a robots file here where we can actually view the robots file directly in the browser, meaning we can see the robots.txt with the sitemap.xml here, and the moment we would go down to the Microsoft site, we stop the Foxy proxy, we write microsoft.com, and we write the robots.txt here. We can actually see that file. And what the robots.txt file is actually for. The robots.txt file is a text file located in the root directory of a web page that provides instructions to search bots called crawlers or spiders about which parts of the site they can crawl and index. It can also restrict search bots from accessing certain parts of the site, such as administrative sections, temporary pages, or sensitive information. It helps search engines crawl the web more efficiently by directing them only to the important parts of the site. With all of this, we can increase SEO, search engine optimization, which is the value of the process of optimizing a website to improve its ranking in the results of search engines like Google. The second file is sitemap.xml. Move permanently to sitemap.aspx. Okay. Microsoft don't have this file. Okay. Let's try another page. This is what sitemap.xml looks like. The sitemap.xml file is an XML file that provides a map of all the pages on a site that a webmaster or creator wants to include in a search engine indexing. This file contains a list of URLs along with other metadata such as last update date, frequency of changes, and page priority. It makes it easier for search engines to discover all pages on the site, including those that may be difficult to find through the normal crawling. But then there is one more file that every site should have, and that is the security.txt file. This serves as a way to list a contact in case someone finds a vulnerability, for example, and would like to report it to the company. So let's go back. Now we are getting to the testing phase, and so as not to attack any foreign sites, let's go over some options for where and how to train. Of course, there are a number of academies such as Try Hack Me or Hack the Box. I like those two academies, for example, and I have a pretty decent status there. Even food, I haven't trained there in a while. Anyway, here on those sites you can train not only hacking web applications but hacking servers who wouldn't know these academies. And as for web applications, one of the admittedly old but still good application is DVWA, or Damn Vulnerable Web Application, and just download and install here again, or DVWA as part of the so-called Metasploitable. Metasploitable 2 is from Rapid 7, which I'm just going to use, where just regarding the web app is just DVWA installed. So I recommend downloading Metasploitable 2, and then the other option is the OWASP Juice Shop project. There you can test a number of web vulnerabilities with the fact that there's even a hero co-op here that's online. And you can try web vulnerabilities here. So then for those who would be a little bit farther along and would like to do, for example, API testing, you can use WAPI to test for vulnerabilities on API, which is fine with the caveat that you pretty much need applications like Postman or SOAP UI to test APIs. For our purposes, I've started the Metasploitable 2 I will show you. Let's wait till it's up and running. So to find out the IP address, I will log in. Default login credentials are msfadmin, and now I have the IP address. As you can see, so here I have phpMyAdmin, DVWA, WebDev, and we'll be interested in DVWA. So I can already try to crack it, but the login and credentials are admin and password. The good thing about DVWA is that you have a certain security level here that you can set DVWA security with the fact that you can toggle here to low, medium or high. In the new versions, I think there's more variation with the fact that if you set this to low here, then the vulnerabilities will behave accordingly. That means I know, for example, when I look at command execution, in addition to being able to try to just attack the input here, I can look at the view source here and see the source code of actually how it all behaves. And now if I leave it open here and I go to DVWA security and I select hide here and I go back and I click on view source here, now we can compare the two codes, and you can really see here that with the low variant it wasn't really guaranteeing anything much, but here it's really guarding the command execution, whether it's actually splitting the input, whether it's actually the IP address split into an octet using dots and so on. It looks at other things, so there's a lot more security there, which of course is then a lot harder to get around. And I think even in the hide variant it shows you how you should set it up properly so that the code is actually secure, because in addition to testing, an ethical hacker should know how to actually do the code or how to secure the thing. Anyway, for our experiments, we are going to set the DVWA security level to low. And we are going to turn on our proxy now. Okay. Just like the request interception worked for us in Burp, the same thing works for us in ZAP, only it's down with this green set break button. That means if I go over here and I want to, for example, solve, let's say, brute force here for a username and password, if I do a test here and click on login here, so I get username and password is incorrect, and now we can look back in our history and see the whole request and the response here. To capture the request directly, if we want to work with it in real time, we just need to check the green button here and go back. Now, if I type admin and test here and I put login, you can see that just like when I put intercept on in Burp, it actually captures up that request. You can see the break here, and I can already play with that request here. Now I don't have an intruder and repeater here and things like that, but I have what's called a requester here. So I can throw that request into the requester here. I can then pass the request on, just like we did with the forward button in Burp. You can see here that we got a response back and so on. So that's how you can intercept requests in ZAP as well, with the caveat that a lot of people just use Burp, because I have heard the opinion that ZAP can't intercept requests. That's not true. ZAP can capture requests just like Burp. So now if we want to play with just the request, the way we send it to the requester, the way we saw with Burp, Burp had a couple of opinions, and I might as well just run the Burp. But I will show you why the communication isn't really good for penetration testing, and it's really better to invest in a pro version at the point. However, if you are testing the site manually, at this point it doesn't really matter if you use ZAP or Burp. We will set our proxy to 8081 because 8080 is used by ZAP. and we will set our test to 8081. This means that whether I put on the test will go through Burp, and whether I put on Burp ZAP will go through ZAP. Now, if I want to do a brute force attack on this login, I will intercept the request in Burp first. So here again I see the same request as I saw before in ZAP, except that now I can of course put it into the repeater, for example, where I can play with it in different ways. I can manually try to override the test to pass here and so on, and I still get the username or password is incorrect. And now we are just going to use what's called fuzzing, where actually in Burp it's called a little bit differently. We can actually just throw that request into what's called an intruder, where we'll mark our password string here and use sniper at this point. And I'm gonna put my payloads here, so I'm gonna need some passwords here. And of course I can download the passwords from somewhere like GitHub, checklist and so on. With the caveat that I know that the password is a password, so I will delete the password for a while. I want to show you how slow the burp scan will actually go, and the more you put payload here, the slower it will be. At this point, when I put start, Burp itself will alert you that the community edition contains a demo version of Burp Intruder. And you can see that it's going pretty slow, and it's going to extend that time even more. 30 payloads will still pretty cool, so let's get some more in there. And as you can see, it's not exactly the fastest. Most of the time it should have a pretty quick response time. And ZAP should have run this a long time ago. Which of course the Pro version of Burp can do too. Here you can see that it's really quite slow already. And the moment you need to test let's say a password dictionary, which will have at least 1000 entries, and so in the community version you really don't get to. That means that for manual testing, not just for a brute force attack, but for some payload of other vulnerabilities, it's just not quite good. So I'm going to close Burp at this point and show you the exact same thing in ZAP. I will put back here so that we don't use Burp but ZAP. We will catch the request again. Or we can actually use this one. I've already got it called here. So I'm going to select this test input here, right click on it and use the fuzz tool here as fuzzer. So the moment I use the fuzzer tool, I can specify the payloads here, and I can put the whole string here, or I can use file fuzz from the ones that I actually downloaded, jailbreak and so on, worthless discovery. Here we can see that there really are a lot of passwords, and we can use the sheet here. So we can see that there are some 24,726 entries, which is a lot, but it doesn't matter. Of course, with the fuzzer, we have other options to set up, like in Burp. Now if we give it a start, and you can see how fast it's going compared to Burp, and it's really trying to run through everything. So I'm going to stop it, and now actually how do we find out if we are talking about this particular sort of manual attack? How do we actually find out that the password worked? So we can figure that out from some length of that response. So we can sort the requests by the length of the response. We can see that normally the size of the response body is some 4.572 bytes, and it gives us the response username or password incorrect. If I sort from largest, you can see that I can get a response with 4.637 bytes, and because of that I find that I get welcome to the password protected area admin in the response. With that said, there are often more things to examine besides response body size and header. For example, the response time is also examined, for example, during SQL injections and so on. But now I just wanted to show just the difference between Burp and ZAP. And using ZAP, you can actually really do a pretty good test for free if you do it manually in addition to the automatic test. So let's go back to the beginning a little bit. I mean, let's go back to our page, and first of all I said it would be a good idea to drop our spider on that page like we dropped on the Microsoft one. I right click on the app and put attack spider here. So here's what I'm gonna do first. Now you can see I've got a few more folders and files jumping in here. So really ZAP has searched all sorts of things, and the next thing we could try is if there happen to be any other folders and files on that particular server that the spider hasn't found. Because like I said, the spider was actually searching the links. And the moment I want to find out if there are any other folders on the server, I can use the forced browse site or directory tool here. Where, as you can see, I'm getting other additional files here. I will stop it now, and if you click on the setting gear on the right, you can actually see the settings for that forced browser. And how it's doing, for example, which endings it's ignoring when it's browsing. So, the GoBuster tool, which is in the command line, actually does the same thing for us, and ZAP is using it right now. You need to install it if you want to use it directly from the command line. Other tools that you can then use are WFuzz and FFuff, for example. So, the moment we actually have those pages run through Spider and GoBuster, then we can either test the individual pages or the whole web application as a whole. But before we do that, let's tweak the scanning policy a bit more. You click on Analyze, Scan Policy Manager, and we have some basic policy. I recommend creating some insane policy, where you put the default alert threshold on a low, which as you can see means more potential issues flagged. So you can drill down into vulnerabilities that normally ZAP wouldn't flag as vulnerabilities. And you put default attack range on insane, which means much more attacks. It's good to do the same here. Now we have alert threshold low and attack range insane everywhere. And just like we showed with Burp what it can do, here we actually see what ZAP can do. Okay, we've created a policy, and now we can right click on page and select active scan. Policy will select insane. Scope we check and leave for now. Input vectors we can leave. Here again we can play around with this custom vectors technology. If we know that, for example, we are running a PHP MyAdmin database in the background, so there's no need to put IBM or Oracle here and so on. Of course, if we don't know what's running there, then it's good to leave the technology, of course. We can set up filtering methods in the filter. It doesn't need to. And the moment we click on Start Scan, we can look here at what all ZAP is actually doing, and we can see that really ZAP is trying a number of different attacks here. And now when we filter the vulnerabilities just for our page using context, we see that we immediately get the different types of vulnerabilities that ZAP found. So an example of that would be cross-site scripting, path traversal, things like that, where we can actually see the individual requests directly, and we can look directly at how that vulnerability was found by ZAP. So let's take a look directly at our vulnerable application. And as we can see, we have the file inclusion module here, where we can see to include a file edit page index.php in the URL, where really in the URL there's some sort of page variable, and as you can see, that's where ZAP was trying to just specify some sort of payload for just path traversal or file inclusion. We can of course intercept the request ourselves, and how we would proceed if we wanted to test this vulnerability manually, we would put it in our request tab. We can see the page variable here, and at this point we would need some payload list again, which I'm going to use the seclist GitHub list again at this point, where we are just going to use the payloads for our file inclusion vulnerability. So as you can see on this GitHub, you can really find a lot of different payloads for any kind of vulnerability. So then of course it's good to use basically almost all the files and payloads to expose different vulnerabilities. But we are mainly interested in local file inclusion now. And now to try and see how we would proceed manually, we would basically need all of these payloads that we need to put into our ZAP for our fuzzing and to examine actually what the page returns. So mark the place that we want to fuzz. We choose payload with the fact that we can use some files, or if we copy from some pages the payloads, we can use them and paste them there. Once we click on Start Fuzzer, we are really going to try again all the options that the GitHub sheet offered us. So now it's back to looking at what the page actually returned to us. I mean, you can see state reflected here, which means that the page actually dumped our payload, which is good for cross-site scripting and other vulnerabilities. But in our case, of course, we can now examine the size response points again, which at this point often vary, which may be due to more payloads passing through them than just the one that ZAP originally found. Thus, it's then good to go through it all. As you can see here, it's really the moment we put some file like var log news or proc.net.arp where we really get a dump of this file and therefore a dump of the ARP table. To show that really part of this payload file is of course the payload at etc path. So we'll just take a quick look for that. And indeed, you can see that really the exact same thing that ZAP found using the automated scan, we would have found using manual testing and using fuzzing. You can see here that we would get exactly the same answer that ZAP got originally. At this point, if we were to actually manually test the page like this, the page parameter would need to be checked for other vulnerabilities as well. That means, for example, just for cross-site scripting, SQL injection, and so on. Nowadays, we have a whole range of attacks that need to be checked, and for this reason, both automatic tests are useful, but it's good to know the specific types of attacks and to know what payloads to use for them. And there are, of course, attacks where you will not be able to use just a separate payload, but you will have to do something a bit more sophisticated or modify something like the Java deserialization attack and so on. So you can do manual testing this way, but we could, of course, test automatically just the one page itself. Just right-click in the history on the request and put an active scan directly on that particular page, where we can select in custom vectors our point where to attack automatically. With that said, if we check disable non-custom input vectors at the bottom, ZAP will stop attacking our other attack vectors. So, and now you can see what ZAP is automatically capturing at this point. The last thing we are going to look at, we have already shown where to get the dictionaries of those payloads or the entire files of those payloads. I have been pointing to GitHub checklist with the understanding that there's more of those GitHub checklists, of course. I'm sure you will find plenty of them. And on the checklist, how I said, you can use payloads for different vulnerabilities. Also, just type something like fuzzing list into Google and you will find a lot of GitHubs. And as you can see, checklist is the first one that comes up. And next you can use, for example, Maverick Nerd word list, which are also designed not only for guessing passwords, but also for fuzzing. And then one last one that I will show you that I use sometimes is the Osamahamat maybe GitHub fuzzing list. where you can find again a different list for different types of attacks. So, and as the very last thing, we'll show that ZAP can also generate reports with those given vulnerabilities that it found. Just go to the report, generate report, where you can set up a template, filter for different things, and choose just the page you want to generate that report for. So we'll find ours here. We will put a generate report, and it will generate a simple HTML report where you will find some summary of those vulnerabilities, what was actually tested, and what's cool. So you will definitely find individual vulnerabilities in that report, but also of course individual requests for those vulnerabilities. Here, as you can see, the vulnerabilities are described. If we go a little higher, you can see the specific requests for those vulnerabilities. So if we take our path traversal vulnerability, for example, and we click on our request, we can see some description of the entire alert, and we can see the request right here. That means we could take it and actually re-execute it, and we can see here what the request actually returned. Thanks for watching, and if you like this video, please like and subscribe and share this channel. Thank you very much.